is 6. And we are also told that the limit as x approaches 4 from either side of 3 f of x plus f of x times g of x is 27. We're asked to find f of 4. That is the question. So just double check that I copied everything correctly. Interesting problem.
Yep, that's right.
Perfect. So we're asked to find f of 4. They're telling us that these functions are continuous. So since they are continuous everywhere, it means that when we plug in 4 in these, in f of x and g of x, we will get a number because the functions are continuous, right? So in that case, I am allowed to write this. 3 f of x plus limit as x approaches 4. I'm applying the limit law of f of x times g of x. And this is disclosed to us to be 27. I know that g of 4 is 6. So when I plug in 4, since it's a continuous function, I get 6. So then limit, remember one other limit law allows us to bring the factor in front. So 3, limit as x approaches 4 from f of x plus limit as x approaches 4 of g of x, since g of 4 is 6. This will be 6, so plus 6. Limit as x approaches 4 from f of x for the same reason, the same limit law, right? The constant goes in front, equals 27. And now let's look at the left-hand side. And we realize that we can basically combine like terms, because we can say 3 apples plus 6 apples. And then we'll combine and we'll say 9. Limit as x approaches 4 from f of x equals 27. Of course, you're going to tell me what I need to do next, and you will say, very good. So then I have that limit as x approaches 4 from f of x is 3. Therefore, what do you think f of 4 will be, knowing that this is a continuous function? Yes. Very interesting problem. Thank you. Any questions on this? Any questions? Thank you. So, anything else about this or anything else? Mason, do you have any questions for today?
Wait, actually, yeah, this was I had trouble on this one too. Sorry.
Okay. So we're given a g of 4 is 6, and we're given this equation. So we can, since the functions are continuous, they're telling us that, then we can apply the limit laws. So first I applied the sum of the limit of the sum is the sum of the limits, and also I applied the constant comes outside. So this is 3 limit of f of x as x approaches 4. And here I know the g of 4 is 6, so I did the same thing. I combine like terms, I get 9. 3 apples plus 6 apples is 9 apples, and I divided by 9, I got this, and that must be f of 4. So functions are continuous.
Okay, so
And we know that when function is continuous, we can simply plug it in.
Okay, so
If it's a rational or polynomial.
So you don't just from the start plugging that f of 4 into the f of x, because that's just not.
That's what I did. I
Yeah.
You don't have f of 4.
That,
Okay.
You are asked to determine f of 4.
I kept getting tripped up on that. I was like, why is this?
Is that clear now?
Yeah,
You can only use the equation and what you're given in the problem in order, hopefully, to get to the answer.
Okay.
Good. Anything else? Anything else?
Yeah.
Yes, please. Thing?
So it was part of the 2.5 on the left side.
Yes.
Question 15.
15.
I have the actual.
15.
It was asking.
So 15 and 2.5?
Yeah. I have it right.
Okay. 15 in 2.5. What does it say? Oh, it's a limit. Okay, very good. Excellent. So we have limit as x approaches 2 from arc tangent. We had something, but not exactly the same. Perfect example. Very nice. I think I'm going to add this to that list of limits because it's a nice example. You know, the handout that I gave you. Good. We're asked to find this limit. Where do we start? What is the starting point? Where do I have to look at first?
Like if it'll get 0.
What I would do is I just plugged it into the inner function.
Of
I wasn't
course.
sure.
That is the
But
correct
regardless.
answer. So first, this is the outer function, this is the inner function. Forget about the limit for a moment. This is a very important discussion. Forget about the limit for a moment. If you're given this function and you're asked to evaluate when x is 2, what would you do first? Right, it makes sense, common sense, right? You have to plug it in here, and then you apply arctangent to whatever you get, correct? Perfect. So let's plug it in and see what we get inside. The numerator goes to,
0.
good. The denominator goes to,
I believe when I did this also.
of course, of course. So 4 times 5 is 20, 10 minus 2 is 20, 20 minus 20 is 0, of course. So what kind of situation is 0 over 0?
It was one of the
Excellent,
indeterminate-
it's one of
it's
the
one of
indeterminate cases. So we have to do some more work. I can conclude, so I have to take this aside, limit as x approaches 2 from x squared minus 4 divided by 5x squared minus 10x. I cannot make a decision. It's an indeterminate case. Okay, perfect. Now I look at this limit. I know it's 0 over 0 because I already tested it. So if that's the case, since I have a polynomial divided by a polynomial, I would like you to tell me which one is the culprit, which one is the problem, which factor is the problem that will hopefully go away.
The x squared. No.
So which factor?
Creates the problem.
You mean x minus 2?
Excellent, thank you very much, Colby. Yes, of course. X minus 2 is the problem. X minus 2 must go away from the top, and x minus 2 must go away from the denominator if the limit were to exist. We discussed that. This is the limit. This is the factor theorem and remainder theorem. Please remember that. Good, so then we continue with factoring. I already know that there must be an x minus 2 in the denominator and x minus 2 in the numerator, no matter what. It's mandatory. Good. Then the top,
X plus 2.
of course, thank you, Vicky. Of course, I will factor out a 5 from the denominator, and also an x minus 2, and what is left? Right, a 5x. Sorry. I should write 5x. I will write it again. That's all I need. I don't need a second set of parentheses. So we only simply factor out 5x. Perfect. And now what?
And you get rid of the.
Right, of the problem. Yes, I get rid of the problem. And then what? Now I will drop the limit operator. There is no need for it anymore. The numerator goes to?
X plus 2.
The numerator goes to? We're talking about when x approaches 2.
Oh,
4.
4.
Very good. The denominator goes to? Good. So this is 2/5. So therefore, this answer at the top is
2/5. Arctangent 2/5.
That's it. Arctangent 2/5. That's it.
We don't find arctan.
But can you?
Um,
If it's asking asking us to determine, but it's gonna be an approximation, we can. Do they want degrees, do they want radians? Let's do that, let's do that.
It just says decimal places.
Okay, well, let's plug it in. I have radians.
Oh, all you have to do is plug it in.
Yeah,
Oh.
oh yeah, we can determine without that. So here's the inverse tangent, arctangent or tangent inverse of 0.4, right? It was 2 divided by 5, so 0.4. I have no idea. This would be in radians. So it would be 0.3805. I don't know how many digits they want. I didn't read the fine print. What did they say?
3 decimal places.
Okay, so then 0.381. If they want degrees, I'm assuming they don't. We don't really use degrees in calc. But if they want degrees, then all we have to do is do this. And repeat. Or simply change 0.3805 blah 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 radians into degrees. But I don't know, they should say something there.
I would assume it's just the first one.
Okay, in radians. So this is in radians and this is in degrees. Very good problem. Thank you, thank you, thank you, thank you. Anything else?
I have one more, 18.
Okay. What does 18 say?
Find the values of A and B and make F continuous everywhere.
Wonderful.
And
Okay.
then it has three
Branches, three branches, very good. So let's take a look at f of x with 3 branches. Excellent. You guys are studying. You make me proud. Thank you. Okay, I'm ready.
So the first one is x squared minus 4 over x minus 2, and that's if x is less than 2. The second one is ax squared minus bx plus 1, and that's if 2 is less than or equal to x or less than 3. And finally, 4x minus a plus b if x is greater than or equal to 3.
Very good, awesome. Great job. Okay. So in this situation, I have a function. It has 3 branches. It's a piecewise defined function. How many variables we see? Parameters, to be exact. How many?
3.
3. 2.
X is in the third one. Oh, I guess you would plug in.
It just
No,
says
okay,
A
fair.
prime and B, right? One more time. So how many variables or unknown we have in this problem?
2.
2.
How many equations we need?
2.
Right, otherwise we can't solve. 2 variables, 2 equations. In the previous example that we looked at from 2.5, we had only a letter, which is a parameter, C. How many equations we needed? Right, but in this case, we have to come up with 2 equations. Perfect. So we want to make this function continuous everywhere, right? Okay. Let's take a look. We have to write and simplify first if we can. I cannot simplify this, I cannot simplify this, but I definitely can simplify this. Everyone can see that, right? Good, so how do I simplify that?
Pull out x minus 2.
Okay, x minus 2 over x minus 2, so I have an x plus 2. Do I have to write that x is not equal to? No, because x is not equal to in here. So the first branch really simplifies to x plus 2. The second one, I just copy, ax squared minus bx plus 1. The last one I just copy. And I make my correction now. Okay, perfect. That was the starting point. I realized that that fraction needed attention. And the attention it needed to be simplified. Was just simply factor the top and simplify. Okay, Step number 1, I have to write that x plus 2 as well as ax squared minus bx plus 1 as well as 4x minus a plus b are as oh, these are what type of functions? Thank you. They're all polynomial functions. So they are always continuous as polynomial functions. Everywhere. So I just wrote both words over there. Sorry. Number 2, continuity at what?
Yes.
No? Okay, I'm on strike. Let's go back to the previous problem from last time. I can be on strike, you cannot be on strike.
Is it negative? Am I gonna be at 2? Is it 2 3?
Exactly. Continuity at x equals 2. And then what? Exactly. Continuity at x equals 3. That is a potential problem. And that's where we have to work. Do the work. Okay, perfect. What does continuity at x equals the number mean? What do I have to write?
That
Yes?
the two equations need to be equal.
Nope. You are way ahead.
It's a
Yes? Back to your notes, please, from last time, please. I'm begging you, please. What is the definition of continuity at a point?
That the limit from the left.
Thank you very much. The limit from the left of 2 must equal the limit from the right of 2 and must equal f of 2. Awesome. That's all I needed. Perfect. So please dictate what function we have on the left-hand side of 2. Dictate the function we have on the right-hand side of 2. I'm ready. My markers are drying.
The left is x plus 2.
Very good.
The right is a
Got it.
squared minus bx plus 1.
Good. And can anyone give us f of 2 right here, right now?
The second one,
Good. So it's
ax squared minus bx plus 1.
one more time, f of 2.
No, f of 2.
Yes,
Sorry.
you're on the right track. But I just need the answer.
So 4A.
Excellent. Yes, 4a. Very good. Minus 2b plus 1. Excellent. Great job. Thank you. Okay. So I should be on strike more often. Okay. So can anyone give us this limit?
4.
Excellent. Can anyone give us this limit?
Would it be the same as? the
Of
last
course. Thank you very much. You put me out of my misery quickly. Good. Okay. So let's repeat for continuity at 3. So limit as x approaches 3 from the left, limit as x approaches 3 from the right, and f of 3. Tell me what I should write when you're ready. Sooner rather than later, I hope.
From the left is.
Yes?
The second equation. So
Perfect.
x squared
Perfect.
minus bx.
Excellent. Yes. Ax squared minus bx plus 1. Very good. And now from the right?
4x.
Correct, very good, thank you. And now f of 3, please.
It's 4x
12.
12 minus a plus b.
Awesome. Good. Now I need this limit and I need this limit. Ready?
9a minus 3b.
Excellent. Thank you very much, Reese. And here?
12 minus a plus b.
Perfect, Amari. Excellent. Good. So this is equation A, and this is equation B. So we found we need to clean them up, etc., but we obtained two equations in A and B. They are linear equations. And now let's create a what it's called what are we creating with these two equations? We are creating a system of two linear equations. Let's see how we solve that. So obviously there is no point in writing this twice. I cannot have an equation with more than one equal symbol anyway. So I will keep 4a minus 2b and move 1 to the other side. So 4a minus 2b equals 3. This is our first equation. Of course, there is no need again to write the same thing twice. So here I have 9a, but I'm bringing an a, so that's 10a. I have a negative 3b, but I'm bringing a negative b, so this is minus 4b. And here I have a 12, and I'm moving a 1. So I completely cleaned up the equations. Now we have to pick a method. We have plenty. We have substitution, which I really don't recommend, unless you want to work with fractions. Elimination. We have Kramer's rule. We have matrices. We have inverse matrix. We have, which method do you prefer? Okay, I'm going to multiply the first equation by negative 2. So I have negative 8a plus 4b equals negative 6. 10a minus 4b equals 11. And I'm going to eliminate b. So that gives us 2a equals positive 5. So a equals 5/2. So I eliminated b, multiplying the first equation both sides by negative 2, all terms of course. 4b minus 4b goes away, they go away, and then 2a equals 5, so a equals 5/2. Now I go back anywhere, it doesn't matter where. Let's say I go back to the first equation with a equals 5/2. So 4 times 5/2 minus 2b equals 3. Of course I will simplify. So that's 10, negative 2b, and 10 moved to the other side is negative 7. So b equals 7/2. So 3 minus 10 is negative 7. I'm checking my numbers also, so this is 7/2. This is good, but it's not good enough. I have to go back and rewrite the function with a and b that we just determined. So let's go back to the function. Original or simplified one, it doesn't matter really. There's no problem here. Any questions before we rewrite the function, please? Any questions? So then f of x is x squared minus 4 over x minus 2 for x less than 2 is 5/2 x squared minus 7/2 x plus 1. And for x, so let's see, negative a, so negative 5/2 plus 7/2 is 2/2, which is 1. So the last branch is 4x minus 1. What do we know about this function right now? Guaranteed. Where?
Everywhere.
That's it. Continuous now on negative infinity to infinity, or when we say everywhere, that's what we mean. Very good problem, thank you. Excellent. Anything else? Anything else? Okay, 2.7 and 2.8 are the last sections of this chapter, so we can start reviewing it now. I don't want to use the title just yet. I don't want to put the title just yet. We're going to talk about it, and I'll come back and put the title in. So, coming back to our graph. Any questions, anyone? I'm sorry, I should have waited. Any questions, Colby? Any questions?
I'm just,
Absorbing it?
yeah.
Okay. Anyone, any questions? Is this clear? Every step? Yes? Okay, perfect. So we're going back to our best friend so far, that P and that Q. And if you remember, we said that they're very close to each other. Well, let's say this is X and this is A. In the past, we used X and X plus H. We'll go back to that in a minute. And we know now that the X coordinates of these, the Y coordinates of these 2 points are X and A.
Yeah.
Very good. And of course, again, we want to determine the slope of this line, which is the average rate of change of function f of x between P and Q. So we want to determine the average rate of change between x and a, which is the slope of the line PQ. Same thing. Can anyone give us the answer? Just a slope of this line, nothing else for now, just a slope.
F of A, F of X,
Mhm.
over X,
Right.
over A minus.
Excellent. I'm just going to write it reversed. Minus over x minus a. And now, if I bring Q closer and closer to P, not P, right? So Q is not P, so I cannot just overlap. But I can bring it closer and closer and closer and closer. What am I really trying to determine?
Instantaneous velocity.
Exactly, or the slope of the tangent line at P. Okay, so what am I missing here? I know that this is almost, so when I bring Q closer and closer to P, I know that this is almost the slope of the tangent line. But I can put something in front of it that we've been discussing for a while, a week or so, maybe 2. What is that thing that I can put in front of it? To determine the slope of the tangent line at P. Exact,
Would it be lim?
of course.
As X goes?
Of course. That's why we discussed this first. Indeed. Of course. Now it's exact. Here, it would have been an approximation. I could bring Q closer and closer, closer and closer to P. But once I put this is exact. It's carved in stone. This is it. This is the slope of the tangent line. Well, this is also called or denoted by f prime of A. This is not only the slope of the tangent line at P, it's also, as Omari said, the instantaneous velocity at P if the function is a distance function, but also the derivative of function f evaluated at a, at x equals a. The derivative of function f of x evaluated at x equals a. Evaluated at a, or at x equals a. So moving forward, we are going to say that f prime of a is the derivative of the function evaluated at a point x equals a. So then this will be a function or a number? A number. It's evaluated. It's not f prime of x. It's f prime evaluated for number a, 3. So this will be a number. So that equals a number. F prime of a is a number. It's the instantaneous rate of change of that function at p. It's the instantaneous velocity at p. It's the slope of the tangent line at p. All of the above. Okay, so this is one definition that moving forward we have to remember. So, oops, this doesn't work. F prime of a equals limit as x approaches a from f of x minus f of a divided by x minus a. This is one definition that joins the other definitions like continuity at the point and so many others. Limit laws, the fact that the polynomial function is continuous everywhere, etc., etc., etc. So let's go back now to our graph. Notation slightly different. Still f of x, still p, still q, but now this is a, and this is a plus h. This is obviously, of course, thank you. And this is obviously f of a plus h. And now, of course, I want the slope of the same line, the secant line. What is that going to be equal to?
Based on the limit, I guess not, f of a plus h minus f of a all over h.
Very good, which is a plus h minus a, but we already know the answer. And now we want the slope of the tangent at P. See how these two concepts, the difference quotient and the limit, come together to give us the derivative. Okay, so now I'm going to put the limit in front. But now careful what? So remember, I'm trying to bring Q closer and closer to P. So then, what do I write here under the limit?
Tell me x approaches a, isn't it? We're trying to get close to p. I'm out. I guess I'm off.
As Q gets closer and closer to P, what happens?
0.
For what?
Like x or h
H.
approaches 0.
H
Of
approaches
course, of course. Very good, awesome. So f of a plus h minus f of a divided by h. And this is the second definition of the same thing. So we have two definitions for f prime of a. So f prime of a is limit as h approaches 0 from f of a plus h minus f of a divided by h. If you ask me, okay, if you give me a function and you ask me to find f prime of a, which definition will I use? I can't give you a recipe. Here's the answer that I will give you. For some functions, this is easier to calculate. For other functions, that one is easier to calculate. Finally, we have one more definition before we look at problems. And this one you already know. I left your baby at the end. Of course, the same question again, the same graph again. This is f of x. Of course, this is our little p and the q. But this time I'm going back to our first drawing, where this is x, and this is f of x, and this is, what did we have a long time ago?
X plus h.
That's it. And this is f of x plus h. Again, I'm going to ask you the third time today to give me the slope of this line, and you're going to say the slope of the secant PQ is definitely what we already know is the difference quotient, and that equals,
F of x plus h
very good,
minus f of x.
divided by h. And now I want to determine the slope of the tangent line at P, where P can be anything. P can be anything, any point, anywhere on the graph this time. It's not a particular a value, or 5, or 10. It's any x you want. What will that be? Equal to
Limit as q approaches p,
the limit s.
h approaches x. We'll figure this out eventually.
Zero.
Of course.
Still,
F of x plus h minus f of x divided by h. But this is not f prime of a, but
F prime of x.
the function f prime of x is the derivative of f of x. It gives, among other things, the instantaneous velocity or rate of change at where, and this is the tricky part. So the function is a function, right? So it gives the derivative of f of x, which is instantaneous velocity, the rate of change, etc., at
any
excellent. At any point, any. When I put my hand on my elbow on this right here, sometimes I don't know, it's very inconvenient. Uncomfortable to put my elbow on that. So, point where the function is,
Continue.
nope. You're close though. It's a word that I haven't used before. Where the function is, yes. We have not talked about this, but now we will. So it means that a function can be differentiable at some points and not differentiable at others, yes. Yes, we'll talk about it right this moment, but let me just clarify this. This is the only definition we have for f prime. We do not have two definitions for f prime of x. This is the only definition. We do have two definitions for f prime of a. We have this definition for f prime of a, which is a number. We have this definition for f prime of a, which is another number. And we only have one definition for the derivative of a function. Carved in stone. Just the limit as x approaches 0 from what? From the, what is this? The limit as h approaches 0 from, what is this? The difference quotient. So we only have one definition for the derivative of a function, which is the limit as h approaches 0 from the difference quotient. That's why I tortured you with this from the very beginning. So the derivative function is the limit of the difference quotient when h approaches 0. Okay, now, let's discuss this, because this is very important. So, when would a function not be differentiable? There are several situations, several cases. So that's our next step. When is a function not differentiable? Here are the situations when a function is not differentiable. So when we talk about a function that is differentiable or determining f prime of a, we mean at the point there is only one tangent. One tangent, one slope. Here's what happens in this situation. The function is not what? It is not continuous. At this point there is a tangent here, and at this point a tangent here. Totally different numbers. So you can determine a tangent. It's not a unique tangent. So when a function is not continuous, it cannot be differentiable. What happens here? In the second situation, I have again two tangents. One that is positive and one that is negative. This is called a cusp. It's something that looks like between two teeth, a cusp. The function does not have a unique tangent there. It has two tangents, therefore it's not differentiable. It doesn't have a tangent. It doesn't have a derivative. This is called a corner. Same thing, a positive tangent and a negative tangent. I do not have a unique tangent at that point. And what happens to the third one? The third one has a vertical tangent, which means that that limit does not exist or is infinite. Vertical tangent. In these four situations, the function is not differentiable. Okay, we're ready for examples now. If you have your book, you can choose. We are on page 151, 152, or I'll show you and you choose. I'm okay with time. Hold on just one second, let me